Hello students, welcome to Secret Heart High School. Today we are going to study in Science-1, Chapter 12, Study of Sound, Part 1. Children, what is sound? Sound is a form of energy which creates the sensation of hearing in our ears. This energy is in the form of waves. A medium is necessary for the propagation of sound waves. Sound waves give rise to a chain of compression and rarefaction in the medium. The particles of the medium oscillate about the central or mean positions in a direction parallel to the propagation of the wave. Now, as you can see, such waves are called longitudinal waves. On the other hand, in the waves which are created by dropping a stone in still water, the particles of water oscillate up and down. These oscillations are perpendicular to the direction of propagation of the wave, and such waves are called as transverse waves. A sound wave can be shown in the form of a graph. At any moment during the propagation of sound wave, we would find alternate bands of compression and rarefaction of the medium. That is, bands of greater and lesser density. The wavelength of sound waves is indicated by the Greek letter lambda, while its frequency is indicated by mu. The amplitude, which is the maximum value of pressure or density, is indicated by A. The time taken for one oscillation of pressure or density at a point in the medium is called the time period and is indicated by T. The value of frequency determines the pitch of the sound, while the value of the amplitude determines its strength or loudness. Now, before you can see both the waves, longitudinal wave and transverse wave. So you can see the difference between both the waves. Next we shall see velocity of sound. Now you can see that the distance covered by a point on the wave in unit time is the velocity of the sound wave. So velocity is equal to distance upon time. Now any point on the sound wave covers a distance equal to wavelength in time t. Thus the velocity of sound is given by v is equal to the product of wavelength and frequency. Thus in any medium at fixed physical conditions, the velocity of different frequencies is very nearly the same. The velocity is highest in solids and least in gases. It increases with an increase in the temperature of the medium. Next we shall see velocity of sound in a gaseous medium. The velocity of sound in a gaseous medium depends on the physical conditions like temperature, density of the gas and its molecular weight. So temperature, if you take temperature, the velocity of sound is directly proportional to the square root of the temperature of the medium. This means that increasing the temperature 4 times will double the velocity. Next we shall see density, that is rho. The velocity of sound is inversely proportional to the square root of density. Thus, increasing the density 4 times will reduce the velocity to half its value. The third factor is molecular weight. The velocity of sound is inversely proportional to the square root of molecular weight of the gas. Thus, increasing the molecular weight 4 times will reduce the velocity to half its value. The molecular weight of oxygen gas is 32, while that of hydrogen gas is 2. So we can prove that the velocity of sound in hydrogen is 4 times that in oxygen. For a fixed temperature, the velocity of sound does not depend on the pressure of the gas. Next we shall see different form of sound. The first we shall see audible sound. The limits of hearing of the human ear are 20 Hz to 20,000 Hz. That is, the human ear can hear sounds of frequency in this range. These sounds are called audible sounds. Our ears cannot hear sounds of frequencies lower than 20 Hz and higher than 20,000 Hz. Sound with frequency smaller than 20 Hz is called infrasound. The sound produced by a pendulum and the sound generated by the vibrations of the Earth's crust just before an earthquake are examples of such sounds. Sound waves with frequency greater than 20 kHz are called ultrasound. The dog, mouse, bat, dolphin, etc. have a special ability to hear infrasound. Thus, they can sense some noise which are inaudible to us. Children under 5 years of age and some creatures and insects can hear waves with frequency up to 25 kHz. Bats, mice, dolphins, they can also produce ultrasound. The ultrasound produced by bats gets reflected on hitting an obstacle. This reflected sound is received by the ears and they can locate the obstacle and estimate its distance even in the dark. Hope so, children, you have understood this topic. So thank you, children. In the next session, we shall meet with the next part.